Hi, welcome to clickmyproject.com. Now we are going to see the title of Robust Perceptual Image Hashing based on Ring Partition and NMF. Here is the abstract of our process. In this paper, we have proposed a robust image hashing based on Ring Partition and NMF, which is robust against image rotation and has a desirable discriminative capability. So that in that paper we have to provide a ring partition non-negative matrix factorization method which is used to provide the robust perceptiveness and good discriminative capability. The key contribution is a novel construction of rotation invariant secondary image which is used for image hashing and helps to make image hash resistant to rotation, and also the NMF coefficients are approximately calculated for comparing the images so as to measure hash similarity with correlation coefficient, and also so that the proposing hashing is robust against content preserving operations such as image rotation, JPEG compression, brightness adjustment, contrast adjustment, and image scaling are also analyzed and provide better results and demonstrate that the proposed hashing is much better than all these algorithms in classification performance with respect to robustness and discrimination. Here is the DFT of our process. Here first we have to select the input image. So that input image is like data, JPEG image or any other images with any other size. So that we have to move the image scaling process. In image scaling process, the input image is converted into resized image with a fixed standard, that is 300 into 300 or 512 into 512. So that we have to move the image pre-processing step. In image pre-processing step, we have to consider that midpoint calculation and radius evaluation. For that midpoint and radius evaluation, we have to divide the image into 7 rings for calculating the image hashing functions. So that I have to find the equivalent distance within from the midpoint to all other rings. So that we have to apply the image ring partition method. In that original image, we have to divide the image into midpoint and also calculate radius, then move to the equivalent distance partition, then apply image ring partition. In that modified image, means in that pre-processing step, the input image is modified by using the brightness, contrast, or like that rotation, and that image is going to that modified image processor, so that the process are applied in that step, image rotation quality reducing process. In that quality reducing process, the image qualities brightness is reduced, so that we have to apply ring partition to that modified image, so that we have to compare the two images, so that NMF calculations apply to the two images. So that when first of all in NMF calculation we have to find the correlation between two images, so that we have to apply the image hashing technique. In image hashing techniques, the correlation value is given to the hashing process. In that process, we have to set our threshold values, that is the limited threshold values is 0.95, so that the correlation value is below that the threshold value means, so the similarity of the images is to same. If if it is wrong means, so that image is a different image. In that similarity process, we have to check that image similarity function. So that in similarity function, we have to identify the two images are same. Now we are going to see the demo of our process. Here is the home page of our process. Robust perceptual image hashing based on ring partition and NMF. Then moves to the next process. Here we have to choose a input image, that is JPEG or any other image with any other size. Here we have to choose one of the image. Okay, the image is displayed in that here. Here by clicking show button, the image name and that image type and the image size are denoted in that panel. Then moves to the next process. Here we have to click the original image. Here the original image is displayed. For the size and name is also displayed. Here by clicking apply resize, the image resize process is applied. So image resized successfully. For the image is resized, the whole content is retrieved in that location. The stored location is the current directory location. The frame size is 300 into 300. So that we have to identify the image name is run.image15.jpg. So the image size is 300 pixels. Then moves to the next process. Here we have to select the resized image. By clicking normalization, the image normalized successfully. So that result is given. Here the image normalization. The particular image is image name. The input images, by reducing the quality factor, the image is displayed in that format. So that reduce quality 1. So that by clicking reduce quality 1, the particular image is shown, and then particular image is shown. Here we have to reduce the brightness contrast of our image. Then move to the apply ring process. Here we have to select input image, any one of the image, reduce quality. By calculating midpoint of the image for calculating the ring partition method. So that midpoint is 150, then Euclidean distance. So the distance is calculated based on the midpoint. So the center point is 150. So the radius from midpoint, the radius is evaluated, and the nearby Euclidean distance is calculated for that image. Then you have to apply the ring partition. So this image is considered to the apply the ring partition. The image is displayed as 7 rings based on the midpoint and Euclidean distance value. The stored location is ring reduced quality. Then move to the next process. Here we have to apply rotation of our process. So here have to select any one of the rotation angle. So by clicking rotation angle, the angle is displayed. So by clicking input image, the input image, so the reduced quality image is selected here. By clicking apply means the image rotated successfully. So that image rotated successfully. So by clicking show image, the rotated image is created. Here by clicking 15, so that image is rotated by the 15 angle. So the image name reduced quality. So that after that rotation, the image is stored in that particular location. That image type, image size are also declared. Then move to the next process. Here choose the original image. The original image means before applying that, the original image selected in that process. Rendered image 15. This is our selected input. So that image is here. Here we are calculating midpoint for that image. The midpoint is evaluated, and also the Euclidean distance is evaluated for that image, original image. Here also apply the ring partition to the original image. Then move to here, the original image is stored in that location. Then move to the next process. Here in the NMF, here we have to move the NMF calculation. So the NMF input are that the ring rendered image 15 and also the ring reduced quality. This is our rotation based rotated image. So the mapped image size. So that here the image size is mapped into 300 pixels. So we have to evaluate the threshold of that value. Of the threshold value is 0.950. So the total number of rings is 7. The number of rings is denoted 7. So here by clicking apply NMF, the NMF is applied to the 2 images. So the NMF is applied. NMF results. We have to evaluate the NMF results. Here the NMF calculation, the temporary folder name is TMP. Nomination prefix, the image is stored in the prefix name of NORM. The width and height are displayed, and the nominate format JPG. Threshold value 0.950. So we have to move the correlation process. Here we have to choose the NMF image 1, that is ring rendered images. Then you have to have the rotated image. So we have to identify the correlation coefficient of that image. So we have to, so the first image is image verification ring reduced quality image. The second image is ring rendered images. So the both are the images are. We have to evaluate the correlation value 0.77. We have to denote the threshold value. The threshold value is 950. So that we have to identify the two images are same or not. So that by clicking verify process, the first image reduced quality rendered image 15. In that correlation coefficient is below than threshold value means the visually the two images are same images by clicking any other modification. So we have to evaluate the two images of same images in that process. Thank you.